Let me first start with DevOps. So we are at the DevOps Con, and we want to know what the principles of DevOps are. So I picked up two definitions, one from AWS. They tell us that DevOps is a combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. So we want to get quicker. Wikipedia, good source always, they say we want to become more effective and we want to have efficient cooperation between software development system administrators. And also quality assurance and the users that benefit from whatever we build. So how can we achieve DevOps? We have some goals. We have speed and quality as the main principles we want to achieve. We have some stakeholders, developers, administrators, quality assurance and users. And now we have these elements that we want to implement to achieve these goals. So culture, procedures, and tools. Of course, management thinks, let's introduce Kubernetes. We have our solution. Now we have Kubernetes and everything is done. We have DevOps, we have quality, we have speed, we have tools. Wonderful. So I want to tell you that this is not the truth. Unfortunately, DevOps has to be implemented using a culture and principles. But of course, Kubernetes is a great tool to do that. So a word about myself. I'm Thomas. I'm working with Kubernetes since a long time. I have some certifications as well. I'm originally started working at an ISP in North Rhine-Westphalia in Germany, and I worked with routers, network, servers, and they were managed by hand, some scripts later, and at that time we didn't have anything like Puppet, Ansible, Pulumi or something like that. Everything was hand-coded, and we were really proud when we built scripts to automate things. Later there was PHP, a wonderful language to kick off scripts, wonderful. So later I studied computer science and moved on to work with Java, a real language, really great enterprise language. And yeah, then I came back to have all my knowledge applied from the ISP days and did DevOps monitoring stuff using modern tools like then Puppet, later Ansible, and of course Kubernetes. So I give trainings about all these topics, and if you're interested, feel free to reach out. So just a short recap about Kubernetes. It's a container orchestrator. Basically, it runs on everything. So if you have a single node machine like a Raspberry Pi, single board computer, it scales up to a data center with thousands of nodes. But the most important thing is it has an extensible API at the core. So I think the API is really the value that Kubernetes provides, because you can extend Kubernetes with your own extensions, your own custom resource definitions and APIs. And I will give a short presentation tomorrow about operators. There I will go a little bit more in depth in that topic. So configuration is declarative. I just specify what I want to achieve, not how to achieve it. The implementation is somebody else's problem. I have a rather simple application example that I use a lot in my trainings, because from my PHP days I love PHP. It's so easy to write something, no compile step, no build step, I can just run it. And we see here some elements that you probably will see when you develop your applications. You need to take care about the environment an application currently is. So when you have a development setup, you probably want some settings to be different from production. Let's say you develop a new newsletter. You don't want by accident to send out real emails to real customers, but have a test deployment. So an environment variable is a good way to configure this. It's a rather old construct, but it really shines now in the age of containers and a lot of environments in parallel. Sometimes we have old-style applications that need configuration files. We can mount them, of course, and then read them. And of course, we often have to do remote requests to other systems to get data, to send data. So usually we use something like HTTP. And here again, we have an environment variable that we use to determine where to do our call to. So when you build your application, you could use Docker. I wouldn't recommend it, but to get a start, it's fine. Just do a Docker build and push it to a registry. This is the Docker file defining this PHP application. And after it's in the registry, you can then define the application and run it. So for example, if you have a Minikube cluster running with an old-style Kubernetes dashboard, you have a wizard where you can just enter, okay, I want a new application, this is the registry address, that's the number of replicas I would like to have, and I would like to have a cluster IP service or load balancer or what else. And I just click deploy, and it's running. That's much better than in the old days. When I remember to deploy an application, I had to SSH to a server. Sometimes even manual steps had to be performed as well. So this is really nice. I don't have to care about which server to run on. Kubernetes will do that for me. So I get a higher level abstraction. So we use tools. That's from the definition of DevOps, so more tools is better. And we now have a procedure for rapid iteration. We can just try out a new application in the cluster. And now developers and operations, they get a little bit closer to each other, because me as a developer can just deploy an application, even to prod, using this approach. But remember, we want quality assurance, we want automation, and this was a really, really manual process. I built the image myself, I pushed it myself to a registry, need to remember the right address, and then deploy it through the dashboard. We would like something like configuration as code. So Kubernetes has a declarative API. Why am I using this dashboard to do everything imperatively? Let's just use the APIs and use the text definition, the YAML format for it. So who of you is working currently with Kubernetes? If that's roughly 50%. I expected really more, but that's fine. So I will take a moment to explain these names here. So in Kubernetes, you can have namespaces that partition your cluster logical. So not talking about these nodes are just for this application, but inside the cluster, you want some kind of order. Like when I get up early in the morning and I'm a little bit tired still, I need to get dressed quickly. So I know in which drawer I have my shirts, my socks, my pants, and so on. And namespaces are a little bit like that. So you have drawers and can put everything that belongs together inside there. The pod is the concept of a workload, so that is what is scheduled in the cluster. When I run this PHP application, a pod becomes scheduled and is placed on a node, and then inside the containers running. Replica set is for availability and scaling, so I can define a replica set that will manage pods and ensure that a specific number of pods is always available, so I have high availability. When a node dies, the pod on that node is dead as well. Replica set notices it and then schedules immediately a new pod. So this is kind of this self-healing of Kubernetes you may have read about. Then we have a deployment. Replica set is just about the number of pods. A deployment makes sure that you can have a process for rolling out new application versions. So deployment manages replica sets and can switch over to a new application version, while the replica sets just manage the pods to ensure availability. Inside the cluster, we have a service concept to have DNS records inside the cluster, so we can find other pods and don't have to care about on which node they run or what IP address they got, and I can just discover them. So service discovery, that's why the concept is named service. This is how it could look like. We have a namespace in the upper left hand in YAML format. That's for our PHP application. So just complete namespace per application, per stage. It's a good practice. Then on the right side, we have the deployment. That is what I created earlier using the wizard in the dashboard. And here I can specify the number of replicas, because the deployment will manage the replica set. It will tell it the number of replicas I want to have and where to obtain the application from. And then the service is used to make these pods available under a common name inside the cluster. So the name is PHP demo, the namespace is PHP demo. So we have PHP demo.php demo cluster-wide available. So now I can activate these configurations using kubectl apply. No more manual clicking and entering variables. And this is nice because when I do some changes in my deployment, for example, I change an environment variable, then I can do the kubectl apply again. Nice. So we have used more tools. We used kubectl, we used a text editor, wonderful tools, and we have a process for even more rapid iteration because no longer I do manual clicks in some GUI, it's just applying the new configuration. It's more automated, I would argue, because I just change the value, apply it, and less error-prone than manual process in the dashboard. There are many times that I stood here and did a demo with the dashboard and mistyped, and then everything didn't work. So I really know what I'm talking about. When you're staying here, there's high workload and you make mistakes. So what we are missing is some kind of quality assurance. We argued that DevOps wants to achieve higher velocity, but also higher quality. So what could we do? We have text files. Let's put them in Git. So source code, application source code, is usually version controlled. Let's do that with our infrastructure code as well. What we will achieve is traceability. We know who changed what and when. And if you write a good commit message, you also know why. So this is interesting. When you're in a regulated field of work, like healthcare or insurance, finance, something like that, usually there is some organization that wants you to have processes that implement exactly this: traceability, review possibility. And I argue that when you use a GitOps approach, then you really get this auditability, and you don't have heavyweight processes to get everything approved by an auditor. Also, Git is a common protocol, so you can use it as a foundation for automation that builds on Git. For every programming language, there is a Git library available. So when you write a Python application, for example, it's easy to Git clone something or fetch some changes from Git and work with that in your application. So again, more tools used. That's good because DevOps is more tools. Process for rapid iteration, yeah, it's a little bit slower. Now we have to push everything to Git, and we need some process to get the data from Git and apply it to the cluster. But we get this possibility to do merge requests, to do reviews with branches, and all that stuff that you know from software development. So it's better for the quality assurance, but we miss this automation. So it would be great if we could use something that automates using this Git stuff. And we know that, again, from software development, there are CI servers, continuous integration servers. So just let's use that again for our infrastructure. There are a lot of tools. Many customers that I work with still use Jenkins. It's proven, it's okay, it's fine. Some use Bitbucket CI, but there are a lot of other tools nowadays that are more or less the same. Since GitHub became popular and GitHub Actions, now YAML format is more or less the language that you want to use to define your build, and all these tools more or less look the same now, so you don't really have to care whether you use GitHub Actions, GitLab CI, Tekton, or something like Woodpecker CI. That's something, if you never heard about it, I encourage you to have a look at. I use it a lot in my CI/CD trainings. It's a really, really small CI server that's perfect for even small labs, but it scales up in the enterprise as well. So what I would recommend when you have a Kubernetes cluster, use it for your build as well. Nothing is more frustrating than pushing a change and having to wait for a build slot, especially in older enterprise environments. I experience that a lot, that there are Jenkins builds and a limited number of build agents, and you really have to wait until the slot is free to get your stuff built. So if you have a cluster, you can scale automatically your build agents, and all the modern tools support that. Even Jenkins has a Kubernetes Cloud plugin so that you can scale your build and don't have to wait for anything. So use it. Yeah, talking about containers and Kubernetes, when you are building using containers, you get a lot of benefits. So we talked about scaling the build, but you can also use tool containers with a specific version. So one of our clients is working in airspace security, so flight control stuff. And they have to support for a very, very long time what they build. So once there was approval for all its stuff and an airport is using their software, you can't change anything without a very, very heavyweight process. So they want for all their customers have specific versions of all the tools involved, all the build steps involved, and they need to prove that nothing changes. So they use containers now, and they can provide all the tools in the specific version for a specific build, for a specific customer, and don't have, like in the past, to have special nodes or special directory path where all the old stuff is prepared for a specific version. Another thing is test containers. If you have never heard of test containers, you should have a look. This is really great. They automate infrastructure using containers, and you can use them in your application source code. So for example, when you build something like an IoT application that should run in Kubernetes, it would be great when during the CI pipeline you could spin up a Kubernetes cluster and install your application and all the other services required, like MQTT broker, database, and whatnot, inside this temporary instance, do all your integration tests and get it tear down at the end of the build. And that's what test containers provides you. So you don't have to write a Docker Compose file or a shell script or something. You can just use it in your software. And when you're, as a developer, on your local machine and run your tests, it will use simply local containers. And when you run it in the CI server, it will spin up temporary containers there. This is really great. So really good for quality assurance and to simulate everything. So you can import test data set in your database and so on, have everything in a defined setup and validate it works. And of course, continuous integration. So we want to have immediate feedback whenever we push something. And this is how a very, very, very simple build pipeline could look like. This is for Drone CI or Woodpecker CI. It's a YAML format. We see here I want to run it in a cluster, so it dynamically assigns pods to run this build. And we have some steps here, and we see first we have a prepare step and then the actual build step. This is using Jib, that's a tool from Google, to build a container image and doesn't need to use a Docker daemon. So this is really nice, really fast to build. And what I also recommend is that whenever you do a build, stamp the version of the Git commit into the application somewhere where it can be retrieved. So whenever a bug is reported, you can trace it down to the specific build that was used to run and where the bug was introduced or discovered. So this is a rather simple way. What I do here is use SED and change this PHP file, and there's a placeholder called version undev, and I replace it with the current Git branch and commit abbreviated hash, so I can determine, okay, what was used to build this artifact. Of course, you want fast feedback, so always make sure that your CI server gets notified when there was a push. So usually you have webhooks. Do that, don't use polling. You waste a lot of time, and it could be even multiple minutes that you have to wait until a build starts when you don't have this tightly integrated push mechanism. So all CI servers, all forges, Git repositories implement this, so just configure it. Wow, we used more tools. Now we have achieved DevOps nearly. So we have a better procedure. We have an automated procedure, no more manual steps to build an artifact. Now we exactly know what version was used, what source code was used to build this artifact, and it's quicker. So we have a process for rapid iteration. And yeah, Dev and Ops, a little bit more integrated. Now the image is automatically created and pushed to the registry. Not yet deployed, but we have the complete build as configuration as code as well. The path we build ourselves with Docker build or perhaps a shell script. Now we have it in version control in an executable format. That's much, much better. So what we would like to have is something like automated staging. Before I come to this, I recommend everybody to have the option to run locally a Kubernetes cluster. I encounter this a lot with clients that they tell me, no, you can't have a local cluster. You need to use this shared environment because it's too hard to get set up on your machine, or it's too expensive, or no, there's security stuff in the way, you can't run locally. And especially when you're developing, you really want to have an isolated environment that you are sure that whatever you change is the sole reason that something changed in your environment, and you don't want to destroy something of your colleague that sometimes leads to arguments. So what I usually do when I work with clients that start with Kubernetes, we have an automated setup using a shell script, Ansible, or whatever works for you, that you can have a local development environment quickly set up and torn down and set up again. So whenever something is broken, you can start from scratch in a defined and clean manner. This is something I really recommend. Don't use shared clusters. So that's like in the old days when we had one database with everybody working on dev. And please don't do anything on Tuesday. There's a demo with important people. Don't touch it and don't break it. So we don't want to go back to that time. So what we are still missing is some way to get this automatically deployed. So we built our image, pushed it to the registry, but currently we still have to deploy it manually. So what about an automated process to do the deployment as well? Kubernetes has an API. When you do a kubectl apply, it's really nothing more than talking to the API server. There's no magic involved. It's the same stuff that happens between kubectl and the API server you can do in your own applications. And You could, of course, use your CI server to execute that, or even execute kubectl. So the same stuff we did could be done by the CI server. Let's see how that could look like. Here are two variants. One is with Jenkins. This here is again with drone. We can see here that the Kubernetes server is configured where the API server can be accessed and the credentials we use to talk to it. And then we use kubectl inside our build to change the cluster state. So we set the image for our deployment, the PHP deployment, to the new image we just built. Same here in Jenkins, looks a little bit different, but it's more or less the same. We do the image push and then we use a kubeconfig from Jenkins, from the secrets, and then we can do the set image here. So more or less the same, different build server, but yeah. We now have a process for even faster iteration. Immediately after building, we have our new version running in the cluster. And we could argue that we now have something like GitOps with Kubernetes. It's not that bad. It's much better than what we had before. We have used more tools, of course. It's always better for DevOps. We have a process for rapid iteration now. So just do a push, wait a little bit, pipeline is running, application is updated in the cluster. So Dev and Ops really get united here. But what I don't like about this is that the CI server talks to Kubernetes. It needs permissions to do stuff, and there is, in my point of view, we don't have the separation of concerns. So for me, a CI server is doing really the integration testing, the building, but not the deployment. Again, we are missing something. Code review, we could have a branch where everything is done, reviewed, and then merged to, let's say, main, and then pushed into production. But it would be great if we could have a separate environment. So in Kubernetes, we have namespaces, and perhaps we could just spin up a review application or review namespace for this application version before it goes to production. It would be great, wouldn't it? So currently, with this approach, we would have to implement separate builds, would have conditions in our CI pipeline to determine where to deploy. And of course, we need something to take into account that in a different environment, the complete configuration may look a little bit differently, like don't use a production mail server, use a different host name for the ingress and so on. What I like to do is to derive from a Git branch the name of a namespace or a convention to use for the namespace and the ingress host name, so that when I have something like feature blah blah blah, that I get a namespace feature dash blah 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 and an ingress subdomain feature dash blah 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 .company.com, and then all other applications are below that subdomain. This even can be automated, of course, using Kubernetes stuff. So if you run for a subdomain, a name server that is accessible to Kubernetes API, you can configure the subdomains as well, or you just use a wildcard. We had these manifests, and I didn't show you an ingress, but ingress has a host name in it, so we need tools to manipulate all these configurations to adjust for a specific environment. And there are some tools I want to tell you about. The first one is Kustomize. I love Kustomize. It's underappreciated in my point of view. It's a really simple tool to use. It has no templating engine like you may have heard of Helm. It's just YAML, and it is very opinionated about what you can do. You can change some fields using so-called overlays. So for example, you have here the basic deployment in the base folder, and then you have a folder patches and can change something like the number of replicas for test deployment. Or you can have complete overlay structures for different environments. It's really, really good. It has limited flexibility because of this opinionated nature. You don't have loops, for example. You don't have condition. But using this file system structure and overlays, you really, really can go quite far. And it can be combined with Helm. So in a customization file, that's the configuration for Kustomize, you can reference a Helm chart in a specific version. And it can be used by Kustomize to render the complete Helm chart, so you don't need to do something like a Helm upgrade or something like that manually. Just use Kustomize and you're good. So this customization file is the configuration for Kustomize itself. You can have something like a namespace override. This here will lead to the effect that all resources we use and all transitive resources we use will get their namespace rewritten. So this is important for our use case when we want to have a specific namespace to be used for our Git branch. Nice. And also, there are some other transformers. So, for example, you can rewrite images, important as well, because we just pushed our image with a specific Git hash as a marker. So we want that Git hash image used in that namespace. And Kustomize also tracks dependencies using some nice little tricks. For example, when a config map content changes, the config map will get a suffix based from the hash of the config content, and then the deployment will use this different config map, so you will get a route restart of your deployment. So no longer you have the situation that you change the config map and don't see an effect because you forgot to roll out restart the deployment, because the deployment doesn't know when a content of a config map changes. So here we can see how this could look like. We have a base folder where basically the basic configuration of an application is. Usually I use for the base folder the production settings, but with invalid host names, so that it does not by accident get deployed somewhere where it overrides an ingress. Then you can have overlays. You have absolutely free to choose how you structure your file system. This is what I would recommend. Just use an overlays folder, and inside there, for each environment, you have a subfolder with the overlays with, that override the values. Kustomize also provides an edit function. So if you have a CI server, for example, have this complete setup here and just want to change the hash of an image. You don't want to use tools like SED or something to edit your YAML. That's why you have Kustomize Edit. It supports changing the image tag of your application. If you want to use Kustomize, it's already at your fingertips because it's built in kubectl. Instead of using -f for apply or create or delete, you can use -k and it will run Kustomize under the hood. Also, you can use Kustomize build to render the complete manifest with all the replacements and overlays and so on. That's nice if you want to inspect them or want to do quality assurance as a step in your CI server or something like that. This is an example of customization that uses our base folder structure. I will show this just a moment again. So here here's our base definition. There could be many, many YAML files here. Just the customization will be picked up and it will reference everything that is used there. And this here is an overlay that applies to base, and we change the namespace to phpprod for all objects that are coming from here, and we change the ingress host name. This is a little bit ugly, but yeah, that's how it works with YAML patches. So we replace the host name of the Ingress PHP demo, and it should use phpprod.localhost in this case. So now we can use that in our CI server. We could just do kubectl apply after we did the customize edit, where we changed the image to use the currently built image, and then we can use kubectl apply -k. And usually all the build servers support something called promotion. So here, this complete step is only run when a promote event with a target environment's prod or production was emitted. So depending on your CI server, this is Drone CI or Woodpecker, you get a UI where the build stops at this stage here. That's the last step before this conditional step. And to trigger the deploy to production, we need to click in the UI and tell it, yeah, do a promote, and I specify prod or production as the target environment. So after reviewing the complete application as it is in the staging environment, just one click in the CI server and it moves to production. So we have this human quality gate. This is really good. Another option is Helm. Helm is a so-called package manager for Kubernetes. It supports transitive configurations even from remote locations. It has hooks you can use to do some stuff after some other stuff happened using jobs in Kubernetes and so on. And Helm 3 and later versions no longer require special components in the cluster like in the past with Tiller and so on. This was bad times. So Helm is great when you are a provider of something like a product and you're giving it to the outside to environments where you don't have a lot of control over who is running it in which environment under which conditions. When you're in a company and you have control over your environments, I argue that Kustomize is really enough. A lot of companies adopt Helm because they heard about it, they used it themselves as a consumer of published Helm charts, and now they get into developing Helm charts themselves and publishing it to their own registry. Yeah, you can do that. It's nothing wrong about it, but it's really a lot of effort. You need to maintain your Helm charts, publish them, and so on. It's much more complexity than just using Kustomize. So from a consumer perspective, I love Helm charts. It's great. So use them, but think about it before you start publishing them yourself. Start with Kustomize. If that's not enough, then move over to Helm, and you can combine them. You can use Kustomize and reference Helm charts, so to get the best of both worlds. There's one more tool, it's called JSONnet. I don't use it, never used it, but I read about it. So I was confident that this table is a good reflection of the complexity of the tools, the learning effort involved. And so when you compare Kustomize and Helm, more or less where one tool is good, the other is bad. So it's a nice complement. You can start with Kustomize and then use Helm as a consumer or even as a publisher if you need it. Yeah, that's what I would recommend. Start with Kustomize. So now we have introduced a lot of more tools. So now we should have reached DevOps, right? We have a process for rapid iteration, even for staging. If you build this with your CI server, you have separate environments where you can review your application, and you have a really good process. Compare that to what we had in the past. It's really nice. What we don't have is a source of truth that is outside of the cluster. So once again, let's say we are in a regulated environment and we need to prove what was in production at what time and point in time, and perhaps we would like to have the option to roll back to an older version. Currently, with this process, we have to trigger the CI server to roll back to an older version, and we don't have a build for that really. And of course, the regulatory requirements are not fit. We can't prove what was in production except from the build server logs or something like that. That's not good. So again, what is GitOps? If we put everything we have so far and put that in a different place, in a separate repository. So I told you about Kustomize build, it can render the complete manifest. We can use this rendered stuff, place it again in Git. And now we have the complete picture of everything operational in Git. That's why it's called GitOps. And we just need a way to deploy that to the cluster. And if we need to roll back, we just use the ops repository and go back to a proven good point in time, a tag, for example, a branch, a commit hash, whatever. And we have rollback. If we now would have a tool that could automatically use that content to push it to the cluster, we would have no longer the requirement to have administrative access by the CI server. It could even be that the CI server is in a completely different network, and really the cluster could be more or less air-gapped. We just need a process to move the config there and the images, of course, but they don't have to talk to each other anymore. So we could build that ourselves with Kubernetes. Don't do it, it's just for illustrative purposes. This is a cron job. So in Kubernetes, you can have a cron job that uses a pattern. In this case, it's every 5 minutes. And a cron job will emit a new job, in this case, every 5 minutes. And we do a Git clone of our repository where we put all our manifests that were rendered by our CI server and apply it now to our cluster. So the build server produces the images and the configuration, but this GitOps job would apply it to the cluster, separation of concerns. This is how the build job could look like. We clone the GitOps job repository first, then we do the customize edit again, change the image version, run the customize build, and the result is a complete manifest of our application, and that's what we put into Git, commit it, push it. And we even have a traceability across repositories, because now we know from our commit hash that we put into the commit message for the GitOps repository which build state was triggering this ops state. This is really great. Okay, but we could use more tools, of course. This was just a way to implement it ourselves, and there are tools for that. And there are not just one tool, there are a lot of tools. So I like ArgoCD, especially when you start, you get a nice GUI, it's easy to get started, but there are alternatives like Flux, Jenkins X, and a lot of more tools, and they mostly do more or less the same. So they do what our GitOps job I showed you a moment ago does, checks out the Git revision, checks differences with the cluster, and applies the changes. Usually there's a rollback option as well, so you can just click in the GUI and go back to an older version. And there are extensions like workflows if you have to do some steps in a specific order or want to get triggered from something, that's also available in a lot of tools. Most of the CIs and CD servers that are Kubernetes affine, they have an API to configure themselves through Kubernetes as well. So in this case, we have a kind application that's an extension of the Kubernetes API for ArgoCD, and we can configure through the API this application here to be used by ArgoCD. So you could build your own developer portal where you can do one click, create new project, and then you use some automation to create the Git repository for the sources, GitOps repository for deployment, and the ArgoCD application and the build job. So to get started, it would be really, really easy. Of course, you have to build it, but then it's just straightforward. There are a lot of options how to synchronize everything. Because we don't have so much time, I won't go into it. but you can influence how ArgoCD compares the current state and the desired state, what to ignore, what to map, and then how to push it to the cluster as well. This would be the complete workflow for deploying with, for example, ArgoCD and Kubernetes. So our nice developer here pushes something or does a merge request or pull request in our source code repo that triggers the CI server. It will build our new container images, push it to the registry, update the GitOps repository here, and our CD server pulls the changes and syncs them into the cluster. And you can see here there is no direct access from the CI server to your Kubernetes cluster. So from a security posture, it's much, much better, the separation of concerns. So I get often asked, what about infrastructure? If we need to provision like virtual machines or Kubernetes clusters or something like that, yeah, it's more or less the same. You use this approach whenever you have something that can be described as code and there's an API for it, you can run it with a similar approach. Especially when you have Kubernetes at hand, you get something like the cluster API from all modern vendors of Kubernetes. So you can spin up new clusters using the cluster API. There are tools like Crossplane that run in Kubernetes to orchestrate outside infrastructure. Let's say you want to have a test environment at Hetzner, for example, although they increased the prices quite a lot, but yeah. So you could spin up a temporary environment using Crossplane, run the complete deployment there, or you want to run a backup, whatever. You can use a custom operator to integrate some other stuff. More about this tomorrow, if you like. I can really recommend to look into operators. This is a nice concept of Kubernetes. Don't use your CI server for that. Use GitOps. You have reproducibility, traceability. You get a lot of these nice properties. I would like to show you how ArgoCD could look like in action. So yesterday I gave a workshop about building sovereign infrastructure on Kubernetes. And I was challenged, hey, could you do that with ArgoCD? And not quite. It was a short night. But this is how the whole stack would look like. Oh, no, not that password again. Oh, yeah, it worked. So this is how far I achieved this. We can see here that we have 24 applications running in this cluster. And some are still progressing, though ArgoCD tries to synchronize the state, but Kubernetes refuses to accept these changes. This is a nice overview you can have on a screen somewhere. And of course, you can get more details about all the applications that are running in the cluster. For example, this is a really complex application called Echo Server. We can see here the repository where this is pulled from. We can see the application is healthy, so no crashing pods and so on. Synced state, so this is exactly what is here in the GitOps repository. And we can see when it was created 2 hours ago. And one was the last change to this application 1 hour ago. All components of the application are visualized here. So we see we have a namespace for the application, we have a service, we have a deployment. The deployment creates a replica set, and we have a pod here. And then we have an ingress that we can even click here, and then we would get to this application. So how do I get back? Didn't test this before. Okay. This is really, really nice if you have this kind of visualization of your complete cluster structure. And of course, you know, when I delete here a pod, it would be recreated by the replica set. But when I delete a deployment, it wouldn't be recreated. Because, yeah, there's no object managing this deployment. But in this case, ArgoCD is making sure that when this deployment is deleted, it's out of sync. The desired state, what I defined in GitOps, is not the actual state here in the cluster. So it will resync everything and make sure that the cluster content really is what I defined. So this is embarrassing. It should move to finished here. So yeah, something is still progressing. I don't see what it is. Let's just go back to the slides. So I didn't finish the setup, but it's really an amazing tool, especially if you have a lot of applications running. And this complete setup I did here with Keycloak for identity, database with Cloud Native PG, and so on and so on. This is completely defined by this GitOps repository. So the only thing I installed in the cluster was ArgoCD and a Git repository where I can push the manifests. Everything else, the complete setup, the wiring between the applications, it's defined in my Git manifest, and I can prove that what is running in the cluster really is what is in the Git repository. So, my conclusion, Kubernetes enables an extremely productive development environment and operation environment. You can use the DevOps principles to achieve really a quick pace, high quality. You need to use the right tools. We talked about tools a lot. And there is some complexity involved, of course. But usually, you build that and you don't have a lot of contact with all these points. So your typical developer in your company doesn't have to care about all that you build in the background. When something breaks, like this progressing here, let me peek. If it's still progressing, I need to understand what's happening there, I need to diagnose it, debug it. Of course, then you see the complete complexity of the stack. But yeah, in your day-to-day work, usually it's really a breath of fresh air. It's really nice to work in this kind of environment. There's some stuff I didn't cover, of course. You need to monitor security stuff. You can integrate this in this complete workflow as well. So new base images with security patches. Something like policies, we didn't cover this as well, but of course you can put network policies as configuration as code and so on. How do we handle secrets in this kind of a deployment environment? Yeah, there are solutions for that. Logging and general monitoring and alerting. So when you run a Prometheus Grafana stack, your applications could deploy a configuration as well, how to monitor a specific application, what dashboards to deploy for an application. This is really great. So that's what I want to show you about GitOps and Kubernetes. I hope you got some inspiration out of it. Give it a try, especially customized test containers, ArgoCDs, great tools. And yeah, if you have any questions, feel free to ask. The same for the remote participants. Thank you. Any questions? Yeah, go ahead. Yeah.
Okay, so the question is regarding the hybrid environment. So part of the application stack is on the Kubernetes OpenShift, part of it is still in virtual machine environment. Any recommendations, or have you seen that kind of thing?
Okay, I hope I got the question right. So we have a hybrid environment, we have OpenShift for Kubernetes, and then we have virtual machines that are not part of OpenShift, just somewhere else running, right? Yeah, get rid of the machines. But you could integrate other tools, like I think Pulumi is here at the expo. Perhaps you can talk to them. You can use something like Crossplane or Ansible, or Terraform even. You could kick them off the same way like we did with Kubernetes. Of course, it's much harder because when you have a virtual machine, consider it already created and running, and now you want to reconfigure it. You need a process for that. You need a tool for that to get into the machine and do the stuff. For provisioning machines, usually all the hypervisors provide an API. So for example, in Kubernetes, you can run kubevert to declaratively run a virtual machine and tear it down and provision it and so on. I hope that answers the question. But yeah, old school infrastructure is always a pain in the ass, sorry. Okay, I think we are out of time. If you have any more questions, feel free to talk to me. Thank you so much. Enjoy the conference.